Good morning, everyone. For our first panel, we'll be discussing, well, a very basic question: why map dynamic cities, which I think is probably apparent to most people here. But we're going to get thoughts from three very important thinkers on this subject. Our panelists first are Mark Montgomery from Stonybrook University, professor of economics. Phil Young, professor of geographic information science at George Mason University. And finally, Keith Clark, professor of geographic information science at UC Santa Barbara. And I should say that Phil and Keith are also co-PIs on the IUCRC Spatiotemporal Innovation Center. So I'm going to structure this. I'm going to ask each of our panelists to speak for about 10 minutes, give us their thoughts. So that'll take up the first half hour of this panel. Then I'm going to ask them to discuss amongst themselves, joined by our keynote speaker, Lee Schwartz, to discuss these ideas for about another half hour, and then we're going to open it up to the floor. So let's begin with you, Mark.
So I'll just give some general discussion of, I have a longer presentation which I hope will be made available, like all of our presentations, for people to look at afterwards. I'm a demographer, and so I'm coming to these issues out of a somewhat different but related tradition. And Melinda mentioned a few minutes ago the difference between visualization and analysis. So in Venn diagram terms, those two areas of activity certainly overlap, right? But they also have their own distinctive characteristics. Analysis begins with a critical question about the quality of data, right? My own interests are in poor countries, so not Europe, the US, or high-income places, but in areas of the world, South Asia, Africa, and Latin America. Those are where the data gaps currently, I think, are the largest and most important. So I want to talk about what we know and what we don't know in countries of that kind. Right? In particular, in low and middle income Asia. Right. So what is the state of the evidence on urbanization in such countries? The state of the evidence is unsound, I would say. It's thin, patchy. There are major gaps in what we know about secondary cities in particular, but really about urban settlements of all sizes. Okay? There are, though, some positive, hopeful developments that have been occurring in the last few years. One of them is this enormous international undertaking known as the Sustainable Development Goals, and Melinda gave you a sense of what's underway there. A major theme in that effort is the importance of environmental risk to human well-being. Okay? Those goals will be monitored. This is now for the first time in such a large effort at the subnational level. And national statistical offices are therefore going to be dragged into a situation in which they will have to gather information and verify it, vet it, right, at the subnational level, which in poor countries has not been the case very often. The problem for us, interested in secondary cities, is that settlement-specific information on these cities is very hard to come by. Again, I'm speaking of poor countries, not the United States. Population alone is not so easy to come by for most poor countries of the world. And if we talk about the many other determinants of human behavior and well-being, education, age, sex composition, proxies for poverty, health, mortality, and so forth, you cannot find in most countries of the world reliable information at the city level for these key indicators. So we should go into this exercise appreciating what we do not have in hand at the moment. I think the largest but fillable gap has to do with census data. Right? These data are irreplaceable, I think. They are not the end of the story, but that is the place, in my view, where we ought to be beginning. Here's what the United Nations, the major source of information internationally on urbanization, tells us about the urban populations of the world. The UN does not get down below the level of 300,000 population, at least insofar as being able to spatially locate its agglomerations. There are quite, Melinda, I believe, showed us the same map yesterday. There are quite a number of places 300,000 and above, but there also must be quite a number of places below that level. The UN tells us that asking the question out of all urban residents in the low-income Asia is what we're looking at now, what proportion live in settlements that are below 300,000 in size? That's in red. Okay, just over 40% of the urban residents of Asia, low-income Asia, live in these small places that are off the map that I just showed. Now, we can get a sense of where these places are if we turn to other forms of spatial data, non-demographic. So, for example, the nighttime lights would indicate that if we're looking at Jakarta, that there are other places in the environs of Jakarta that are smaller. We don't know how populated they are because lights don't tell you that, but that's a place, as you were doing with that change detection map, where you could begin to focus effort. If you're in a situation in which you're looking at an area where there are large cities, here's a map of Punjab, Pakistan. Those purplish dots are the cities that the UN monitors. The green are other cities, smaller than that, and those in size, that the National Statistical Office presents information on in terms of total population. And with some effort, we can geolocate those. And then the pepperish sprinklings around there are cities that are smaller still, towns, and so forth, as detected by nighttime lights. Okay, so by a combination of orthodox but geolocated data and satellite data, we can begin to fill in the picture. All right. Let me now briefly show you, give you a sense of some of the remarkable developments that have been underway in India. That I think for the first time, and we'll hear more this afternoon about these, what lay behind these developments. For the first time, a country of this size is putting settlement-specific information on the web, listing by name, by population and other characteristics, settlements as small as tiny rural villages and going all the way up the scale. All right, that is an unprecedented endeavor. We're taking that information. If we were simply to graph the number of urban places, so looking, setting aside the rural villages, just graphing the urban, we would get a chart of this kind. The lowest level here are places under 50,000 in size, and then going all the way up the scale. So this is a kind of Zipf's law sort of graph that it wouldn't be too surprising to see. Now, if we ask how many people live in these urban areas of different sizes, the picture looks rather different. The tiny number of giant places turn out at the very top to have quite an appreciable number of residents, as we would all know. But at the bottom of the graph, those small places that are below our level of appreciation in terms of analysis and programs often have an enormous number of residents when considered in the whole. If we're interested in particularly disadvantaged or vulnerable population groups, such as children, we can also, with these materials, locate where children live, and the number in each size class. The horizontal axis is shifted in over here. And likewise, proxies for poverty or for poor health, illiteracy being one such. We can again get a sense of where these potentially disadvantaged families and individuals live. Spatially, let's take one state in India, in the southeast Tamil Nadu. This is the kind of spatial picture one would see if the picture is limited to only the largest places, the sorts of places that are monitored in terms of population size by the United Nations. Chennai is the probably most recognizable city there. Now, what if we were to take this picture and fill in the locations of secondary cities? That we can do with these very recently available data. and the picture looks like that. There's a lot more by way of large-ish human settlements that are urban, going down, in this case, to the 10,000 and below, and then all the way up the scale to the Chennais of the state. And so you can begin to, with those sorts of materials in front of you, you can begin to ask, how well are these smaller places connected to the larger? Are there some that are disconnected from the places where economic growth is underway? What are the transport routes and so forth? We can also ask what sorts of environmental and climate-related risks these smaller places are facing. So we could ask, well, of all those cities and towns that one sees along the coast, facing the Indian Ocean, what are the numbers of people? What cities lie in the low elevation coastal zone? And what sorts of places lie in the pathway of appreciable cyclone risks? Okay, so we begin with these basic, simplistic overlays, and we can count up not just the number of urban residents who are in the pathway of risk, but also get a sense of their characteristics. How many women, how many children, how many illiterate people are in these kinds of situations. So just to close these remarks, I would conclude by saying that this is a wonderful moment, actually, to begin to push an agenda on the smaller secondary cities. We have force and, in a sense, backing from the Sustainable Development Goals process, which will be placing urban settlements in much higher profile than was true in the Millennium Development Goals. It's a moment where we have the other kinds of materials available to focus attention on the environmental risks facing urban residents of small places, medium-sized, and all the way up. It's a moment where at least we could begin to think about the possibility of disaggregating within cities the data that we have. That's still not generally going to be possible, but here and there, this country or that country, that can be a doable objective. And of course, we can combine these orthodox demographic tools with some of the new, the longstanding or newer satellite-related sensor-produced data in a very, I think, hopeful way that will help us monitor change taking place between censuses. So it's a great moment to be doing what we're doing. Thanks.
So our next speaker will be Professor Phil Young from George Mason University.
Well, thank you, Jason. And in answering the question posed to this panel, I put up this title, Why We Need Dynamic Mapping of Secondary Cities. Really from a global and innovation context, say why we need this. So we are in a world which we're experiencing a lot of problems, naturally and also human-induced. Climate change, wildfire, dust storm, and we are having the Earth observation, the satellites, and the in situ sensors help us collecting data sets, try to solve these problems. But once we get those, we also have the problems of these, how to use the data to deal with the problem globally distributed, and how to deal with the big spatial temporal data, which Lee and we all kind of talked about, and I believe this was also a topic of yesterday, and how to deal with the global dynamics of sharing and accessing to the data sets. I have a few slides to talk to this point about how to do that and what is the challenge behind it. And also the complexity and the interdisciplinarity that drives us to work together to solve really problems. What is the driving of all this? So why we need this, in fact, we are living in a world which is not static. Although something appears to us is very static, the nature is changing, it's dynamic, and also the human-induced activities are changing, which is kind of represented on the bars on the lower here. So when we deal with anything on our home planet, we have to think about dynamic, especially for mapping. So in order to deal with that, we come up with different infrastructure. Once we have those data sets, we need infrastructure to support, process, and get the information we need so that we could solve the problems. I believe the driver of what kind of priorities we have, the data sets we have, will be those applications, those problems we're trying to solve. So we could have a computing infrastructure or the cyber infrastructure which sits, for example, centralized like this. But this is not enough because we're talking about global. And so if we look at the nationwide, we can come up with some infrastructure like this with several nodes coming together. But really for the secondary cities around the world, we need some kind of infrastructure like this. And this map shows volunteered computers that we have across the globe. And when you look at this map, look at the details, you can see that where we really need the secondary cities is really where we don't have much infrastructure to help us support managing the data, store the data, and also processing the data. So that's a challenge we need to deal with. And based on those physical infrastructure, we can come up with all kinds of software and analytics and mining and applications being supported by this, like Melinda was showing, using the ArcGIS online software to help us do this. But there's more challenge than just visualize those data sets and putting them together in a visualization tool. One of them is that when we get big data sets, like petabytes of data sets, it becomes very hard to access those data sets and pull those data sets in real time to responding to emergencies. One of the things we have been doing in the past is to come up with different types of index. For example, this considers the spatial temporal indexing of the data sets so that we can get right to the data sets when we need them on a distributed infrastructure. And based on this, we could piece together, for example, in this case, different satellite images and manage it in a better fashion so that we can access the data sets in a very fast fashion. Let me see. For example, if we have a global, this is probably the highest climate simulation of the globe, which includes big data behind this. Eventually, for the IPCC report, they envision about 100 petabytes of data sets. But the challenge is that we need to detect from these petabytes of data sets what is the anomalies, which indicates that where are the cities that we need a lot of attention to, and we need to collect a lot of data sets to be responding to the problems or the emergencies that is appearing. So this is another example about how to simulating and see how the So if we have this kind of nature disaster come, what kind of data infrastructure we could have? This is an example using the Phoenix area and also the dust storm, how that will change the public health and how that will change the traffic patterns and how that will change our behavior outside of outdoors. Should we stay at home or should we go outside? So as we see, we have a lot of global and regional challenges. In order to deal with this, as both Lee and Jason introduced, we're coming up with an idea of the IUCRC Spatial Temporal Innovation Center with three aspects. One is on the thinking side, we need a new mindset about considering all the different factors, interdisciplinary, dynamic, and put them in the context so that we could have a good mindset when we go to solve the problem. And another part, we need the tools to help us to solve the problem. We need the software to manage the data sets, and we need the models to simulate the results, and we need the visualizations to help the first responders to make decisions. And of course, we need to make those applications to really solve the problems. So with that, we have this center architecture, and we also deal with and pull out the research topics. The data comes up as the biggest here, the big data. And as a center objective, we want to do the innovative research, and hopefully that will become products and services or tools, for example, like ArcGIS.com or other tools like BeamMaps that could be utilized to solve different types of problems that is facing us by different agencies and others. I want to bring up another topic which is really driving the requirements for the secondary cities or any cities in terms of the data infrastructure and others. So this is a slide I took from Chinese colleagues, and they're dealing with the smart cities. This is one of the movements around the world, especially in South Asia. And they're looking at what kind of infrastructure we need to support a smart city. And they're looking at, okay, in the center, we need some kind of infrastructure that could help us manage the data, collect the data. And also, we need the platforms to put together geographic big data, and also the smart city ecosystem, which means different types of applications. For example, public safety, public service, business and industry, and planning, and many others. And all those could come together in a sustainable fashion. So what they have been looking at is that different applications, for example, smart transportation, and what we need in terms of data sets, computing infrastructure, modeling, and decision support tools, and also smart health. When we have problems like public health disease breakouts in the secondary cities, how do we deal with that? And also the public safety problems, how do we be better prepared if there's anything, for example, terrorist attack comes up, or even detect that before that happens. And also smart public utilities, how to consume the utilities in a smart fashion. And the education and scientific research, and also serving our citizens in a smart fashion. And the way for collecting those data sets is really lies in the Internet of Things. They talked about, okay, whatever we're using, whatever we're doing, wherever we are, we have some devices with us which could help us collect the data, and also which could help us detect where we are in terms of the context. So that means we could utilize those Internet of Things to collect the big data sets we need for human geography. And also that means we have the computing or the device to help us visualize the results and do the model simulations, provide the decision supporting information. So by putting those two together, in terms of from a spatial temporal innovation perspective, how do we think spatial temporally in responding to the dynamic mapping of collecting big data, have the infrastructure to manage those big data, and make it sustainable and eventually smart. And we need to think, have a new mindset, and also we need a good computing infrastructure in terms of both tools, software, and hardware, and also building those smart applications that could help us drive the demand for collecting the data sets, and or prioritize what kind of data sets we're going to collect, and also what kind of innovations we're going to have. I leave this table blank. I hope this could start some kind of discussions. Thank you.
Thank you, Phil. Our final speaker, Keith Clark from UC Santa Barbara.
Okay, well, good morning, everybody. I bring a slightly different perspective. I'm a geographer who specializes in cartography and GIS. and therefore I bring that perspective to secondary cities. And I want to start by introducing a fundamental mapping problem, and I think this talks very much to Lee's satellite that we saw in the keynote earlier this morning. And that's that when we deal with mapping, we're essentially dealing with two types of features or objects on the Earth's surface. The more easily visible ones are those that are visible from satellites or from aircraft, and they include roads, streets, highways, power and communications infrastructure, airports, water features and resources, the kinds of things that we map and have mapped for many years. But the more problematic features, and the reason, as Lee said, human geography is difficult, is that we also map fiat features, or things that only exist really in our own minds. And these include toponyms, the place names that we give to features and regions on maps, buildings in terms of their specific function as places of interest, rather than just objects on the landscape, land uses, or how we react to and place our own human activities on the landscape, which has both a type and an intensity. I already mentioned places of interest, but government institutions, buildings, military bases, institutions like hospitals, parks, schools, etc. And then last of all, we deal with the cadastre, which is the pattern of land ownership on the landscape, which has an enormous impact on the way the land can be mapped and indeed used. And here's a little background image of exactly those kinds of features from OpenStreetMap for our very vicinity. Again, Lee introduced this idea of VGI, and you even quoted me on it, and I've seen within my career us going from a model of authoritative mapping, in which essentially the central mapping agencies conducted the large-scale mapping and pushed that down to the general public. In the United States, that was done by the US Geological Survey. It took 114 years to map this country first time at a scale of 1 to 24,000, something we now do every 5 years. But in other countries, it's often done by public or sometimes military institutions, and this often leads to some systematic coverage, some unsystematic coverage, usually standardized products because they're being made to national standards, but often closed distributions. So we often, for example, the first time I went to Colombia, it was illegal to own any 1 to 50,000 quad that covered any area of the boundary with any other country. We've seen the transformation to this model of volunteered geographic information, in which citizen scientists or the general public contributes information with no funding in a very ad hoc and non-spatially systematic way through these bottom-up procedures, often utilizing online open resources like OpenStreetMap. I'll mention that in just a second. From the non-fiat point of view, we also have new mapping technologies that are revolutionary. Drones and LiDAR, open imagery and availability of software, structure from motion methods, which I'll show you what I mean in just a second, mobile devices and social media as sensors, means that at last we're finally getting our big data stream about non-fiat objects on the landscape. You might argue that in the end we won't need the satellites anymore because we'll have so much data that we won't know what to do with it all. And the other thing I'd like to point out is that time series are far more common. And time series can work in two ways. We can have a map of the world in which every feature knows its history, so we know when a particular building was built, when it was demolished, for example. Or we can have snapshot views at different time places, like a movie in which we can run one year after another. So I'd like to talk about almost instantaneous mapping. This is what I mean by maybe one day we won't need the satellites. I recently bought a Phoenix 4 drone. I took it out of the box for one test flight. For the second test flight, I decided to do it and map the chemistry building at UCSB. So here's the drone taking off. Sorry, it's fuzzy. It was taken from a video. There's the view from the drone just a few seconds later. I simply programmed in the building I wanted to map. It buzzed for about 10 minutes, came back, and after about 15 minutes of processing time in the Agisoft software, I had a three-dimensional model of 2 different chemistry buildings on the UCSB campus. This is revolutionary. This is changing everything. The other aspect of change, this bottom-up aspect and user contribution comes through OpenStreetMap, just one model of many different VGI initiatives taken within the cartography world. OpenStreetMap is a systematic map of the world that's being created in 2 ways. One is that users are contributing the GPS traces usually from their drive or bike ride every day, which can be logged in and then are conflated and built into the map. Or sections of the map can be downloaded in any one of 3 or 4 different visual editors, overlain with aerial photography, and new features can be captured and then checked into the world map. And I chose Chiang Mai, Thailand, because it's a good example of user contribution. This map has entirely come from residents of Chiang Mai, but I chose Chiang Mai for a second reason that we'll see in just a minute. So that explains mapping, I hope, but what about dynamic mapping? What's the difference between mapping and dynamic mapping? Well, from the point of view of mapping, dynamic mapping involves changes in extents, for example, of urban areas. It involves changes in the features, in which features change their characteristics. So a residence changing to a doctor's office, for example, is just as big a cartographic change. Urban function has changed. Changes in class, in which, say, agricultural land suddenly becomes wetlands, or vice versa. Or changes in the Fiat descriptions when, for example, a city annexes another community or decides to redistrict itself. We have changes in the boundaries. And even our standard mechanisms for measurement, like the census, we change our boundaries pretty much every decennial census, just from a practical point of view. But I think that dynamic mapping involves more than just simply mapping at multiple time periods. I believe it involves forecasting, predicting, and understanding change. If you can predict change, you can anticipate problems, which is, I hope, what we want to do. For this, we often require models of the future, which are often calibrated by historical data. And historical data means that we need to look at not just the current state of the Earth, but the way it was 10 years ago, 20 years ago, or ideally 100 years ago. This doesn't seem to want to run. Oh, yes, perhaps it will. Here's one of the first efforts I made at dynamic mapping. This is from a paper I did 20 years ago now, in which we went back and recovered the historical extent of urban areas in the San Francisco Bay region over a period of some 100 years or so, and then put it together into an animation. This took just hours and hours, months of work at the time. Now we could probably do this in a matter of minutes. I mentioned Chiang Mai because it's a favorite city. It's one of the first times that by publishing my urban growth model as an open source model, it was picked up in a country, and then native intelligence, you might say, in this case with some help from Taiwan, was able to apply the model and use it for forecasting not only historical but also future growth in Chiang Mai using an open source model. So I think that we should regard not only the mapping data elements as elements, but also the models themselves and the forecasts as elements. I was delighted to see in Harvard's world map yesterday that the world map time frame runs from the creation of the Earth to 300 years in the future. I think that's a good time frame. So finally, let's get to secondary cities. These are cities that are primarily dominated by primate cities. I'll explain that in a second. They're normally between 500,000 and 3 million inhabitants, although you'll find variations in those numbers. Increasingly, they occur upon what we now call the long tail. I'll show that in a second. They're often relatively unknown outside of their national or regional context, so their function as an urban area usually is far more regional than national, so we tend to know less about them. You've probably heard of Bangkok. I don't know if you've heard of Chiang Mai. These are undergoing historic rates of urbanization, probably the fastest level of urbanization we will ever experience in all of human history. It's happening now in these cities. It's primarily due to the same reasons urban growth has taken place over the last 200 years, and that is rural to urban migration, increased natural growth within cities, although that's relatively short-lived, and increasingly international migration. So just as the United States city growth, including here in Boston, was fed by international immigration, that's increasingly a source in other countries too. And perhaps you might argue that secondary cities are also least able to deal with their own urban problems. Now I talked about primate cities, and this comes from Zipf's rank size rule. Here it is applied by nation. So Zipf's work on the principle of least effort is sort of standard theory taught within geography. Here we notice that if we take the population to a power, the logarithm of it, and map it against rank, we come up with a relatively straight line which most of the world seems to fall into, with a couple of exceptions. These two, I don't know what you call them, mega urban systems within India and China. Perhaps we should call them peta-urban systems these days, or terra-urban systems. So, for example, if we look at the top, here we're going from zip to zips. I love that. If we zip within countries and look at populations, then we have to go down to about the 25th largest city in China before we reach one that reaches our 5 million criterion, simply because the largest cities, Shanghai, Guangzhou, and so on, are just so enormous. But if we go to a smaller location, let's take Uzbekistan, which I chose because I was working on, but I'd forgotten that they have this wonderful exhibit of photographs from Uzbekistan right here outside. We see that only Tashkent within Uzbekistan falls up at 2 million, and then we hit the lower boundary, the 300,000 boundary within the limits, and the cities that I've been working on, like Andijan, which you see over on the right-hand side, showing extraordinary growth since the 1930s, are all in this bottom realm, but rapidly growing in size and therefore becoming new secondary cities. So we have an explosion of the population of our population centers, if you want to think of it that way. So why should we be involved in mapping secondary cities? Well, obviously the bulk of future growth in the urban extent and the population, as we saw from the demographic slides earlier, they're going to be focused in these cities. These are often going to be the focus of the ills of urbanization, street flooding, water and power supply, which is often interrupted or barely available in much of the world, waste and sewage disposal, enormous kinds of problems, especially when you add rapid industrialization, which produces toxic waste and throws it into this mix. That includes human health, poverty and the war on poverty, violence, including political and social violence, crime, and corruption are all focused in these areas where there's less dominance within the legal systems. This is because local governments are often weak and ineffective, or relatively, I shouldn't say, probably often is the wrong word to use politically. It is sometimes weak and ineffective in these cities, and there's clear evidence of that as we move around throughout the world. The delivery of services to an urban resident is relatively low, and the hazards, for example, for flooding and landslides, is extremely high. One of my students is working on landslide hazards in Brazil. The dynamic mapping of these and the anticipation of change is therefore essential for triage. Which cities face the greatest risks and where should we devote our efforts? Because there's so many of these, it's impossible to focus on all of them simultaneously. Here's one example I use in my classes of a street scene in Varanasi in India, good example. So what are the costs and benefits for dynamic mapping? Why should we worry about this? Well, I'll just give some examples. If we can assess landslide hazards and evaluate, say, favelas at greatest risk in Brazil to landslides, we can simply move population and take them out of risk zones. We take for granted that FEMA will tell us what our flood risk is when we buy a house in the United States. That doesn't exist in many other places. We can anticipate traffic congestion and air pollution. If we expand a particular suburb with new population, it changes the dynamics of the traffic flow. And congestion has an enormous cost upon the urban system, both in terms of time lost, but also production of air pollution. We can provide sustainable water supply. Another student of mine working on this right now. Water supply is probably the most essential issue. I love coming to Boston because you can turn on the faucet without feeling guilt. It's actually take a shower that's more than 30 seconds. It's wonderful. We're on our third consecutive year of involuntary 25% water use reduction in Santa Barbara. Responding to emerging infectious diseases, this is increasingly built into the infrastructure, and then evaluate inequitable or dysfunctional government boundaries. So if I haven't exceeded my time too much, perhaps I'd like to share a few thoughts. First, I believe there's a massive unmet need still for basic mapping, not dynamic mapping, but basic mapping. And I've cast back over 20 years now, to Estes and Moynihan's paper of Maps of Myths, in which they proved that only 10% of the world in 1996 had been mapped at a scale of 1 to 50,000 or better. And I would argue that we've made massive improvements in that, but I don't think we're above about 25%. We're still down there. We need 4-dimensional GIS because we need to track space and time, and Phil talked briefly to that. New technologies for mapping are a real opportunity. VGI within countries is a vast untapped potential. And the example I usually use in class is Dharavi in Mumbai, where a community that won a legal settlement against the city used the money to create a GIS that was used by the local community for planning. I think this is a fabulous model for what could be done for the future. Many forecasting models available and many now being enabled by the kind of computing that Phil talked about, high-performance computing in the cloud. So to me, an issue is how do we model such that model results can be integrated into planning more effectively. And then lastly, this is not a short-term problem. When we convert something to an urban area, usually we're talking about a century's time scale. You pour concrete, it's going to be there for a very long time. So the consequences are long-term, and they're going to be the problems that our children and grandchildren are going to have to face. So thank you.
Okay, thank you, Keith. I'd invite our 3 panelists to come up to the front podium, and Lee Schwartz, if you could join us as well. If it's possible to get the lights on. I think I can do that myself.
Oh, great.
So I thought we would begin by having the panelists discuss the various challenges and potential solutions and the case studies that we've seen presented in these first 3 talks. Before we open it up to the floor, and here I would like to hear first. I'd like to hear Lee. What are your thoughts on what you've seen in these last 3 presentations?
Well, I think. First of all, I think fundamentally that population is still one of the critical features that we need to do a better job of mapping, as Mark brought out. We never have enough information about the simplest feature often of human geography, and that is where people are and how they interact with the environment. So we can't lose track of that as we move towards our more sophisticated tools and methodologies. I would like to accept Phil's challenge of filling in his matrix by, at the end of the day, maybe going back to that chart and having people offer their own thoughts that we can take away with us in terms of how we use this group to fill in the challenges that he introduced by what needs to be done still in those areas he mentioned. And as far as Keith's comments, one challenge that I think is particularly vexing is this whole issue of change over time. Very often when we engage in a participatory mapping exercise and do a tremendous job of mapping missing cities and refugee settlements where there was absolutely no digital data that existed anywhere on OpenStreetMap or in government records, we pat ourselves in the back and take a big sigh of relief, and then we realize a year later that there's no process in place for updating those data. So and we haven't figured out how to incentivize something that is often initiated by governments or grants or cooperative efforts that don't have something built in to keep them sustainable. So the whole question of how do we incentivize volunteer mapping, and how do we sustain it over time if indeed it has value not just as a one-off, but over time and space. How we automate it perhaps, and how we know when change happens that needs to be updated, because we can't update all the world all the time. So who decides what priorities are to keep up with the change? So those are just quick and dirty impressions of the presentations we just saw.
I'm really interested in the question of how bottom-up activities join up with the sort of top-down or authoritative, I suppose, mapping activities. Someone brought up an example of a poor community, Dharavi, in Mumbai, that had organized around the concept of mapping itself, enumerating itself. That there is a long history of that in India, beginning actually in Mumbai, but in other places as well. There are urban poor associations that have taken that kind of activity since the mid-1980s as the core of their effort to bring themselves to the attention of government. Right? So part of this is a question of how do maps come into being, right, at a fairly local scale. There are episodic situations in which a poor community exerts time, effort to map itself, but you can't expect poor communities to do that on any continuing basis. Right? Why, in the end, should poor communities do things that ought to be the province of local government or other governments to do? So I'm as we all applaud the voluntary, self-generated mapping efforts, wonderful activities, I think we also have to ask, where does this go? How does this process put information in the hands of those who ought to be responsible for improving services, access, and so on, i.e. local and mid-level and national governments? I don't think we can lose sight of that connection.
I'm always a fan of use cases. In fact, when I hear about all the presentations today, it's about, I think probably we're missing something, or I didn't hear very clear about that part. What are the problems we want to solve specifically in terms of application? We know we need to collect data sets for the secondary cities, but let's see, this big project is sponsored by state and also NGA. So what are the applications we really want to drive? Hopefully that could help us to prioritize first, which cities we're going to deal with. Melinda showed that a bunch of, how many of them? About 10 of them. So that I believe there's a rationale behind that to select those cities. Another part is that once we have the use cases, we know what kind of data sets we need at the minimum or at the first stage. And also that drives what kind of infrastructure we need to support the analysis of those data sets and also to solve the problems. And that will help us, in fact, better position ourselves either on the statistics or the modeling of the cities or the infrastructure. So yeah, that's one point I want to throw out.
Okay, I'd like to pick up on some of the work by Sandy Pentland that was presented yesterday and how it relates to mapping. In the work that some of my students are doing, and I'm seeing elsewhere, we're beginning to tap into the data stream on human movement and human function and behavior that I think Sandy was really trying to get at yesterday. The problem for that is that the only really available data are the streams that come from social media. And to be honest, those represent only a 2% sample at best of things like Twitter or Flickr. And those are usually only the ones that are geotagged. So we're looking at the world so far from the human behavioral point of view, from the point of view of urban, rich, elite owners of smartphones. And I really don't think that's a very good way to look at the world. I think an enormous amount has been done to connect the world with mobile devices, but we tend to look at the top end of that system rather than the bottom end. When I was working with National Geographic a few years back, we funded a project in India that was about remote diagnosis of simple diseases just by using text, SMS text transfers. That was an enormously successful project. It was very cheap. It was less perhaps geographically enabled, but it was able to collect really good health data very quickly. So I would like to see at least academia, perhaps the mapping community, de-emphasize the social media and start looking at the bigger picture of how we track human movement. And that may or may not mean tracking mobile devices. Increasingly, we're seeing other types of devices that track human movement and behavior, like Fitbit and so on. And when that data goes public and becomes available, or even say, we saw movements from, I think it was Uber and Lyft being shown yesterday, those are really beginning to get at some of the issues that we need to focus on these problems that I highlighted in my discussion.
Well, eventually, if we can make everybody wear shoes in the world, 2 shoes per person, maybe we can have all shoes.
Yeah,
equipped with
ironically,
some
they
sort
all
of
have
device.
cell phones before they have shoes.
Yeah.
Yes. Right.
I have to say, as somebody that makes use out of historical satellite photography, especially the first generation of declassified intelligence photographs from the Corona program, I like the emphasis on starting from a further back baseline in order to track, in order to create models for where development might be heading. This will quickly run into the problem of the fact that there are many, is it petabytes? Is that the bigger number that I don't understand, that's inconceivable to me, of this, well, this is film, has to be converted into petabytes, and then it has to be georeferenced. I wonder if this isn't yet another thing that could somehow be sent out to volunteers. So I think at this point it might be good to open up to our group. Questions for the panelists here.
Hi, thank you for the wonderful presentations. Couple of comments and a question also. I was really glad to see 4D GIS come up. I think that's really necessary for this kind of work, and I'd like to hear some more details about that. And the other one, I think the cell phone conversation is really important because, for instance, in India, I think the biggest revolution was in having access to mobile technology, and the fact that every person almost could anywhere in the country could get a cell phone, and because landline implementation in India could take anywhere from 10 years or so on. So cell phone, the access to a phone for every person was huge, and it encouraged, it really opened up in terms of employment and in terms of other resources. So if we have mapping applications or anything, through cell phones rather than through computers, and that are cheap, or other apps, that would probably be more useful. And so I wanted to hear if there's any development going on with those kinds of work. And lastly, I guess just as an aside or a brief comment, I think, Mark, you're absolutely right about the community mapping history. And I think just being a little bit pedantic here, that VGI is far more individual. And really what we are in India or in developing countries, what really drives this is community-based mapping and basically public participation GIS. So I think that's really important to understand, because VGI is also happening in these countries only amongst the more middle class. So there's a class distinction there, there's a digital divide there, there's kinds of individual response, but the marginalized communities usually don't do VGI. And so that's something I think we should be aware of. But if we can talk a little bit about 4D GIS and cell phone mapping type work, that would be great.
Well, I have a brief comment. I think the discussion over participatory GIS, community-based mapping, VGI, that is really missing the point of good data. I think we need to, and not even authoritative data. I don't like the term authoritative data, because whose authority is it based on? A lot of government data that is authoritative are not good data. So I think if we focus our efforts on the best possible data, then whether it's done through a research grant directed free and open, full participation. If we just think at the end of the day what we need are the best possible data available, then I think that can smooth over a lot of the question about class cleavages and access to media and all the other issues if at the bottom line the goal is the best possible data. You can get trapped in some of these arguments as to what is voluntary, what's not voluntary, what's true participation. So that's my perspective on this as a government promoter of geographic information. I just look at whatever projects get the best data available, and that usually involves a combination of multiple players, multiple tools and techniques, multiple partnerships, and that's why it's so important to bring groups like this together.
Yes, just from comment on the first 2 points, you asked about 4-dimensional GIS and also the location-based service or the smartphones that could help us make our life much easier. On the first aspect, the 4-dimensional, I think when we talk about 4-dimension, we mainly refers to X, Y, Z, and T. And there are a lot of research in this regard, a lot of publications on GIS, and also a lot of new tools coming out. For example, the integration of the animation into ArcGIS or ArcGIS Online. And also we see a lot of visualization results that I presented. Some of them are developed by us, and some of them are in the Spatial Temporal Innovation Center. Some of them are developed, in fact, by NASA and other entities. So there is a lot of research on that aspect, especially dealing with X, Y, and T. Take out Z first. So the way for managing those data sets is really just expanding the 2-dimensional X, Y to T. But if we want think about X, Y, Z, and T, that's a completely different dinosaur. We have to come up with new models. And this kind of problem has been dealt with in the geoscience community a lot. Sometimes we think them as geographers. Sometimes they focus on their own research. But they do deal with those data sets, for example, in the data structure, data format, this HDF, CDF, they would be able to support 4-dimensional data sets. So from that angle, we can borrow some from there. But in terms of the core of GIS, the analysis side, I think we're still missing a lot in that regard. And for the visualization end, we pretty much could only say 2-dimensional, although we say, okay, we have T over there, we're animating, but it's still 2-dimensional at the same time. So that's what my take on that. I know Keith has a lot of research or understanding of that too.
Perhaps I could just chip in. To me, this is a good example of why it's only possible to approach these problems from multiple disciplines, because to naively think that GI science can suddenly discover time is indeed naive, because other disciplines like climate science and physics have been dealing with time series analysis for many, many years, and even have some very refined and sophisticated methods for dealing with it. So it's a question of fusing those in. I would have to say that the analytical tools are not there yet inside GIS. So it's impossible to say, drive a Fourier analysis at a point in a field over time. We haven't even really worked out things like temporal interpolation. How do you take uneven time series and make them annual, let's say, so that we can animate them or analyze them on a more continuous basis. So there are still some really good fundamental problems still to answer, but I think the field is very much moving in this direction.
So in fact, that means it's a very exciting field and it needs a lot of research, and there are a lot of results will be coming out of this. On a lot of topic on the mobile phones or location-based service, we see that the price of the smartphones has been dropping a lot. And we have many more people than, for example, 5 years ago or even just 1 year ago. In many developing countries, a lot of people have smartphones now. But as Lee was saying, we're still struggling to put 2 shoes onto everybody's feet. Sometimes it's not doable. It's impossible to get a smartphone for every citizens on the Earth planet. On the technology side, we see that the smartphone really comes with a lot of convenience for us. For example, when iPhone comes, we have the maps coming with them, the location-based service. And if we look at the history of this, the information enrichment is increasing, the functionalities are also increasing, but how much GIS functionality would be able to be available on the smartphones versus that we need a computer to do the real work on the analysis. I think that still needs time to see how that evolves. That also requires the support from the infrastructure, or for example, how good is our network infrastructure for our phones, and also how powerful is our smartphones, which becomes pretty good. In fact, the smartphones we have today is much better than the laptops we have 10 years ago.
I'd like to follow up just for one quick question before. So Phil, do you think that an investment by local or federal governments in subsidizing availability of smartphones would pay off in terms of potential data collection? Is this a direction that would? I can see some.
About smart shoes and solve two problems at the same time.
Yeah.
I'm going to do a Kickstarter if anybody wants to join my smart shoe company.
It would be a top-down intervention in possibly getting bottom-up data.
Yeah, I think we need analysis about the economy behind this. Is that real? Would gain us something for the developed areas? Even in developing countries, like we're talking about in China, some places the people care more about the environmental issues. And if each of them get a smartphone and they can detect those information and send it back in terms of that way so that they can get the response from the protection agency, probably that will be worthwhile. Because after the problem happened, if you go to clean it up, that costs much more. And in fact, I think a lot of cities in China and other developing countries are considering that. Not every cities, but some places where they're wealthy enough to be able to provide that in terms of get rid of other problems which may be introduced. So the trade-off between the cost in the long term and the cost they have to put up front, some of them are doable.
Thank you for your patience. Yeah.
Hi, thank you. My name is Jim Fitzsimmons. I'm with the Census Bureau. And this is mostly a comment. I just wanted to follow up on Mark Montgomery's point by noting that governments might invest more in shoes or they might invest more in cell phones, but they already do still heavily invest in censuses. We're now getting ready for another round of censuses for around the world. Most countries of the world do collect census data. They collect it at various scales. It's sort of hit or miss. But for basic age, total population, age, and sex data, the data often are available at subnational levels. Maybe not always at what we need to talk about secondary cities, but sometimes, yes, there is overlap there. So as Lee noted, we have to make sure we don't lose sight of the fact that knowing how many people there are and where they are is pretty basic to all of this, and the censuses remain one element in the picture.
Let me add, because we always criticize censuses in developing nations. I've worked quite extensively with census data from South Africa and some other countries, including Brazil, and I find that data extraordinary. I mean, for what resources they have available, it's amazing data.
Yeah, some countries do just a wonderful job at that. And the Census Bureau, in fact, has as part of its mission that we provide technical assistance and capacity building to other countries. And it's one of the real pluses of our work that we are able to see after working for some time, watching other agencies with various levels of success grab the task and make it their own and really do an excellent job, sometimes with pretty limited resources. I'll also add that the Census Bureau, we've begun the task of putting together in systematic way data from other countries around the world. That task is a very big one with some variables, but again, with age and sex data, I think it's within reach that we can put together a solid layer, if you will, of age, sex data for the countries of the world at subnational levels. And as I said, we've begun working to do just that.
Thank you again for the excellent panel. Thank you very much. I want to reiterate that there is a dichotomy, as I hear the discussion here this morning, between the satellite people and the geographers on the ground. I work on civil space issues with satellite people all day long in the Bureau of Oceans, Environment, and Science at State. And from my perspective, the problem is really too much data. April 26, just last month, the European Commission launched satellite Sentinel-1B, the second of their radar satellite. This is the fourth satellite of the Sentinel series, part of the Copernicus program, for which there is already, the money has been spent, 4 to 5 billion euros, for a total of about 10 to 12 Earth observation satellites. The Copernicus program may get renewed, and there will be another series of that. Now, I'm not going to talk to you about what's happening in Asia, with Japan, Korea, India launching more and more satellites. It seems to me that the problem is actually too much raster data. And if we're not using enough raster data, like Melinda mentioned, well, we have a problem here because we're not using what we already have. Can the panel want to comment on this?
Speak to that from having chaired a study on the NGA at one point. I heard from an NGA director that only less than 10% of all the imagery collected by the NGA is actually looked at by a human being. And not that it's not looked at, mostly it's computer algorithms that are finding things. My very first textbook, I had this sort of future fantasy, or 2 or 3 of them, that I embedded in the end of the book. And one of them was a satellite that was so intelligent that it imaged, processed, interpreted, and mapped and sent the results back rather than just raw images. And we haven't really gotten there yet. We still simply download raw data and do all the processing very laboriously and slowly, truly on a large scale, as Phil showed us. But it's the intelligence that we want. It's not the data. And where that funnel takes place in the stream is a very, very important issue.
Yeah, let me add to this by asking, what is it that we want to know that is not delivered by smartphones and not delivered by satellites? If I want to know in a particular population how vulnerable that population is to various forms of environmental risk, I need to know not just how many people are there and where they may travel in the course of a day, a week, or a month. I also need to know how educated they are, how old they are, male, female. These are things that smartphones, under most circumstances, do not reveal, right? Satellites are not, in their current form, able to detect these sorts of important socioeconomic gradations. So as we talk about what's good data, what's bad data, there is clearly a pressing need for some cross-field conversation. As a demographer, I see some items as essential. Other people from other fields may put their emphasis in places where I don't put my own. But I do think we cannot lose sight of the basic markers of vulnerability and socioeconomic well-being that are not detectable or not revealed by these electronic means.
Well, I just think ethics notwithstanding, we need to be prepared for a revolution that most of us can't even comprehend at this point in time with the change that's taking place in technology and processing speed. And so it's just a word of caution about too much data, because I think we haven't even touched the potential in 10 years from now that we might see when everyone will have a smart shoe. But so that's always hard for us to think about in our own science. Sometimes we have to sort of step away from it and anticipate that there's going to be a lot happening that we don't understand and can't even comprehend. And I think a lot of that will allow the discovery into the type of behavior you're talking about, and the type of behavior that we heard yesterday from the keynote as well, that Keith is not there now, but very well may be there, a decade from now.
Yeah, just want to add to this. Yes, in one degree that we have too much data, but on the other aspect, we don't have enough data, or we don't have data. I was just participating in another meeting. It's a LASA meeting, AST, the Advanced Information System Technologies. And we were talking about, okay, we already have those satellites, the birds flying in the space, and they're taking data sets, sending down the data sets every day. But at the same time, when we need to make decisions, we still need more frequency in terms of time, and also in terms of the resolution, spatial resolution. So that's why a lot of, in fact, industry or companies come in, they shoot up birds and taking all kinds of data sets like Skybox and others. So that hopefully could provide us more continuous data sets that could inform us on decisions. But on the other angle, I think what you're really trying to get to is that with so much data out there, what is the real information or knowledge that we can get? That probably is a key. So what we discussed yesterday or in the community is with data out there, the key for getting the information out is really the mining algorithms and big data analytics. And for example, the deep learning, and a lot of those could help us. There are some useful products which are already available. For example, Home Depot use Google service, help them to count how many cars are parking on the parking lots. And also with smartphones, we can take a picture of for example, the text, and then that could help us translate the information into the language that you can select. In fact, this probably partially could solve the problem that Lee come up at the beginning in the movie. So yeah, we do have similar technologies like that, but still, to dig out the real information and knowledge, actionable knowledge, there's a lot of research needs to be done in terms of mining and big data analytics.
Do you have another time for one more?
Thank you very much for the great panel. Sometimes we see that people's knowledge or citizen-generated data is being misused by local governments or being instrumentally used for decision-making processes. So I would like to know, and I like Mark's idea that we need to look at how this information is being used, although VGI is very valuable and local knowledge can be very valuable for decision-making processes. We also need to look at how this information is being used in the process of decision-making. So is this part of the focus for Secondary Cities project, or what do you think about that?
Well, I'll begin the discussion. I've been quite concerned with geoprivacy for the last 3 years or 4 years, and looking at technical solutions for it. I think part of the problem is that much of the data that are collected now at the sensor level from human beings is no longer volunteered. It's actually it's what's called ambient geographic information. So my phone is on, it's tracking me right now. I'm not revealing that information to anybody, I hope, but not necessarily true all the time. I might have clicked yes 2 years ago when I set up an app on my phone. So the problem here is that the law behind personal privacy was written for the era of fax machines and analog telephones, and it really doesn't know or understand wireless technologies or mobile devices. It has a lot of picking up to do. Some good progress has been made in the last few years, mostly at sort of executive level within the government, but I think we still need to go a long way towards assuring what I think we would assume as American citizens is our privacy rights over mobile devices. On the other hand, obviously there's value in it, and sometimes there's value in committing to it, I could receive benefits from being tracked, or I could, it could save me from a heart attack or something like that. So it's a question of weighing the benefits and the costs. A lot can be done with this data, and a lot of it's being done. It's not being done by government. It's being done by private corporations, and they're using it to market stuff. And they're making a lot of money in doing it.
I could provide some examples of when participatory geographic information was misused by the parties that it was intended for. But your specific question about the secondary cities project is built into that project is that all the data collected are open and shared among all the partners. So that is a condition of being selected for a secondary cities project. And in fact, we've had more instances of governments providing information that was proprietary and private companies joining in to provide information that was only heretofore commercially available to participate in that project. So at least by design, the information shouldn't be misused by government any more than it can be misused by anybody else who has access to it.
Thanks.
Okay, we are, I think we're about at a good stopping point now, so we're going to move on to our next panel. Thank you to to our panelists and our keynote speakers.
Coffee break in there. There's a coffee break in there.
Is there a coffee break?
You don't want to keep people from their coffee break, I don't think. I have a special request. If I can be a bit disruptive, when Jim introduced himself before from the Census Bureau, I realize that many people may not know who everybody here is. So at some point before lunch, if everybody can think about a 10-second, literally no more than 10-second introduction of yourselves, we should be able to get around the room in about 2.5 minutes. And then during lunch, people might find out that, oh, he's from that place or she's from another place, and you can put things together and talk to each other. So we'll figure out how that's done, but no more than 10 seconds per person. All right? Thanks.
So are we doing coffee break?
What's that? 10 seconds.